Well,
All
I
right.
think it's probably time to start.
It is noon right now.
So I want to warn everybody that I'm in the Lake District in England, and the apartment that I have, which is a lovely little apartment, but it has neither Wi-Fi nor cell phone signal. So I'm actually out. See if I can turn my camera on. There's a way of doing this. I know there is. Just briefly, I'm in a park where it is raining, but I'm under a tree. And so the sound won't be particularly good, and I'm turning my video off to save on bandwidth. That said, I just want to start out by saying the last couple of weeks I was in Cape Town, South Africa, where mostly it was rainy and cold there too, because it's wintertime. But a couple of times I did get to see the Southern Cross and Alpha and Beta Centauri. So that's my astronomical report. Dennis, why don't you start off by telling us, oh, actually, Bob. Bob, tell us where you are and what the weather is.
I am in Clinton Township, Michigan, and the weather is absolutely beautiful today. And for the Perseids, I saw two. I saw one go across that way, and I saw one for the first time come right at me, which was really cool. Yeah, it just went poof. I thought it was a plane waiting for the second flash, and there's nothing there. I'm like, wow, okay. But so that's my report.
Okay. Dennis, where are you and what's the weather like?
Denver, partly cloudy, going up to 90 today.
All right. And Chris Olson, Chris.
Hello, I'm in sunny Batavia, Illinois, and it's really nice out, pleasant weather. Hopefully we'll keep sending it over to Bob.
Okay. And Carmen in Uruguay, where I'm sure it's winter.
Yes, it's winter, windy, cloudy, and stormy for 10 days now.
Okay. And Tom, where are you?
North of Philadelphia, it's 85 and humid.
Okay. Eiichi, where are you at the moment?
Yes, I'm in Tucson, Arizona. So this my background is my neighborhood, and it just looks like this outside today.
Okay. And Larry, you're also in Tucson. What's the weather like with you?
I'm also in Tucson, north of campus. It's supposed to be cloudy. I'm not sure if it's supposed to rain or not. Probably just going to rumble this afternoon. High supposedly in the low 100s.
Okay. Reverend James.
I'm in Southington, Connecticut. It's 77 degrees here, cloudy, rainy, and some of the towns are in danger of being flooded at this time. Pretty dry, though.
Okay. Jim, how are things up in Anthem?
Good morning, everyone. Yeah, I'm just north of Phoenix, and today it's going to be clear, but it's going to be over 110 degrees. So it's still the summer in Phoenix.
Okay. Fernando, where are you and what's the weather?
In Munich, Germany, and the weather is initially cold, today raining in this moment.
Okay. Jeff?
Okay, well, I'm in Manorville, New York, and it's 75 degrees and cloudy. So,
okay, Linda. Oh, so go ahead, Jeff. Tell us.
Oh, no,
what else did you
just
see?
want to say I got some of the Perseids. I finally got up in the middle of the night to look at them after all these years, but I saw about 7. Take it easy.
That's not bad.
Yeah.
Okay. Linda, where are you?
Allentown, Pennsylvania. It's on the weekend, it was really stormy and lots of rain and clouds and everything. Now it's better, and it's actually going to be quite nice and sunny for the next week. Probably 75 degrees.
Okay, Justin Golden.
I'm in Watertown, Connecticut, 75 degrees today, about 50 miles north of James, and we had 9.5 inches of rain yesterday, and there's a lot of flash flooding going on here.
Oh my. Richard Sam.
Corpus Christi, Texas, 87 degrees and cloudy. I just wanted to know what the last time we talked about the bubble sextant used for navigation at that, just using your eyeball, but just looking at the Artemis that's going to the moon, it's going to use just look at the stars and guide its way to the moon. Just
Yep.
Using the ephemerides or
Ephemerides. That's always a tricky one.
yeah. Okay.
I've heard professionals trip on that one.
Okay.
Yeah. One of the big stars they use, as I recall, is Canopus, because there's not too many other bright stars nearby to confuse you. Okay, Maureen, where are you?
I'm in New York City, Manhattan. It's about 81 degrees, and I'm looking at AccuWeather and their forecast. It's beautifully sunny right now at high noon, but the prediction is for tonight, tomorrow, and Wednesday, more thunderstorms like the ones we had last night, which were noisy and real gully washers. The streets are very clean right now.
Gary, where are you? Gary Port.
Hi. Hi, I'm in Milwaukee, Wisconsin. It's mid-70s and it's clearing now after a weekend of rain.
Okay, James Kaczynski.
Hi, up in Eau Claire, Wisconsin, so about 4 hours from Milwaukee. Pretty much the same story as Milwaukee. It's going to be a beautiful day, low humidity, kind of that pre-fall feel. I missed the Perseids, kind of, but turns out we had a pretty robust evening of Northern Lights in town, so I shifted my focus from Perseids to Northern Lights.
Fabulous. Michael.
Yes, sir. I'm also outside of Phoenix, and it's like, I think 85 today, going up to 107.
Okay. Yes, Katie.
Hi, haven't seen you guys in a while. It's 75 now. I was almost cold this morning when I got up in Pasadena, California, because it was 68. Oh my goodness. But it'll get up to, according to my watch, 93 today. I'm getting a little tired of it.
Okay. Chris Graney.
Hey, I like you am in a park under a tree. It's just gorgeous weather for August. It's 80 degrees, a light breeze, is sunny. I think I'm somewhere else besides Kentucky.
Wonderful. Chris Kennedy.
Hello, reporting in from Queens, New York. I've got my camera off because I've got a nasty case of COVID, but that headshot is much better looking of me than what you'd see. Haven't been outside, but I'll trust Maureen's observations since I'm not too far from her. Mid-80s with more rain on the way. Stargazing conditions in New York are typical, which means non-existent.
Okay. Helen.
Hi, good afternoon. I'm in Lutherville, Maryland, which is north of Baltimore City. It is hot, hazy, humid. We have the after effects of Ernesto going up the coast. So like a lot of you, a terrific thunderstorm last night, and I think more rain to come. And sorry, and my camera is off because I'm on my lunch break from work, so I might be multitasking later in the program.
Okay. And it's now actually really pouring rain, so I'm glad I've got this tree here. Marianne Reese.
Oh, hi. This is the first time I'm with you all.
Oh, so the idea is just tell us where you are and what the weather is and if you saw anything interesting this last month in the sky.
In the sky. I'm a moon watcher.
Oh, excellent.
The other day. And I'm really near Helen. I'm in Towson, Maryland. And
okay.
It's very muggy, but it's sunny. So and the storm was very stormy. And that's lovely. Thank you.
All right, great. Well, this is normally the time when we'd get Paul Gabor to chime in about what's happening at the telescope, except he's not on right now. And there's not much going on in the telescope because this is the month of August, which is the time when the engineers are up there making things run. He did tell me that he'd been up there this past week, trying out some of the tweaks that Project Soft has implemented to the robotic program. Larry, do you know anything more about what's happening there?
I do not know anything. I'm hoping that the stuff that we need for images was taken care of, but we haven't heard back from him on that. And
All right.
also, as far as I know, he's working on either ordering or making final decisions on a camera.
So he's quite busy. Also,
Yes.
just as an update, every 2 years after our summer school, we choose one of the summer school students to receive the McCarthy-Steger Fellowship. And our fellowship awardee is due to arrive in Tucson late Wednesday night. Paul will be the one to greet him and have him sign all the paperwork, and with luck, hand him his first check. I mention this because this is a phenomenal thing for young students. Raffaele Bertolotto is coming to us from Uruguay, and there's really no way that he would be able to get the kind of visibility to get into a program in astronomy, a PhD program, without a fellowship like this. So we're supporting him for a year at the university. And the fellowship, of course, is funded by donations. So if you're interested in that kind of work, check out our website where we talk a little bit more about it, or, write to me or Chris Kennedy. That said, this is really all about the summer school. I know there are a couple of summer school alumni in this group, and one of them is our feature, which is Eiichi Egami. So welcome, Eiichi. Am I pronouncing the name correctly, first of all?
Yes, Eiichi. Thank you.
Eiichi. And let's start out by describing a little bit of what's the astronomy you do today.
Yes. So as many of you have probably heard about, there's now a fairly new large space telescope in space launched by NASA. It's called James Webb Space Telescope. It's JWST. And it was launched on the Christmas Day of 2021. So it's been operating for a few years. And actually, University of Arizona, a team at the University of Arizona built one of the instruments, which is called near-infrared camera. The principal investigator is Professor Marcia Ricci. So the group here, NIRCam, it's called NIRCam Instrument and Science Group, and we've been preparing for we had been preparing for the launch for many years, and then after the launch, we tested the instrument and then started to take excellent, very exciting scientific data. So it covers a large variety of science fields, like from exoplanets to the most distant galaxy in the universe. But so that's what I've been working on.
What's the particular science that you're excited about? Are you a galaxy person or an exoplanet person or what?
Yes, I'm a galaxy person, so I'm especially interested in distant galaxies. And since we built this instrument called NIRCam, we have a large amount of so-called guaranteed observing time. So typically, in order to get observing time with NASA Space Telescope, you have to submit an application, and the applications will be reviewed. And then if your application gets ranked higher than high, then you'll get time. But since we had built this instrument over a period of like 20 years, we were guaranteed to receive several hundred hours of observing time. So we use big chunk of this time to observe two patches of sky very deeply, and we're discovering the most distant galaxies. So that's what I've been mainly interested in, and also there's another special. Although NIRCam is an imaging camera, it also has the capability to take spectra of a large number of galaxies at the same time. And I especially specialized in this mode. I led the commissioning of this observing mode. And so I'm using this particular mode called a wide field slitless mode. I'm using this mode to conduct a survey of large number of galaxies. So those are the few things I've been mainly working on.
Fantastic. You mentioned you've been working on this for 20 years. Can you actually put a date as to when you started working on preparing this camera for the James W. Webb Telescope?
Yes, so I actually joined the team just about 10 years ago, so 2000.
Oh, you're a latecomer then.
Yes. But so the project itself started, I think, 10 years before. And then, but at that time, there was another NASA telescope called Spitzer was just launched. So I was mainly working on that project, ongoing project. But PI, Marcia Ricci, just left this Spitzer Space Telescope project and started to work on this JWST. So I just first 10 years, so I wrote in my introduction that I joined University of Arizona in 2001. That was mainly to work on this infrared telescope called Spitzer Space Telescope. So after the first 10 years, I worked on a variety of different things, Spitzer Space Telescope and then Herschel Space Observatory. And then after 10 years, I joined JWST NIRCam team. So yeah, I'm a fairly newcomer, but there are even newer members in the team who just joined several years ago. So yeah.
Okay. Well, tell me how you got into astronomy. Where did you grow up?
Yes, so I grew up in Japan. So I got my bachelor degree in Japan at Kyoto University. And then
Is that where you grew up, in Kyoto or near Kyoto?
No, actually, I grew up in Tokyo, but I went to
Okay.
my university. And then after that, I went to University of Hawaii for my graduate study. And that's when I went to, I had the opportunity to attend the Vatican Observatory Summer School in 1990. And actually, I'm really glad to see Fernando Cameron here because he was in the same year. So we attended the summer school in the same year, 1990.
Right.
And
I just got a note from John Stockey who says to say hello to you guys.
Okay, yes,
So,
he was the instructor. Yes, John Stockey.
Right. Well, we're going to get back to that a little bit, but first I just want to know what made you interested in astronomy? I mean, growing up in a big city, could you even see stars?
Yeah, so I think I really got interested in astronomy and in the space in general when I was very small, like in elementary school. So back then, during the winter time, there was a sort of homework, which was to just go out at night and identify some constellations, famous constellations like Cassiopeia or Big Dipper. But then at the same time, I read a very science book for child. It's about very basic explanation of Einstein's special theory of relativity. It was written in a very simple words, and then so main thing was that even light, it takes light to travel. It takes light time to travel. So that if you are seeing a star 3.6 light years away, what you're seeing is actually the light emitted by the star 3.6 years ago. So in the same way, most of the stars, they're far away. So then I realized that when I was looking up at night, looking at those stars, I realized that all these particles of light, which is hitting my, eye, they were emitted many, many years ago when probably, there was no human being on the earth. So at that point, I made sort of the connection, and then that wonder still stays with me, and that's when I got really interested in astronomy.
Well, that's of course exactly the same thing you're doing now. You're using that time travel as a time machine. You're looking back into time to the beginning of the universe.
Yes. So now the farthest galaxies we discovered, I think there was a press release which came out just a few months ago. The most distant galaxies we've identified, it was light travel time is like more like on the order of 13 billion years. So that's, you know, as you probably know,
wow.
that the age of the universe, current age of the universe is like 13.8 billion years. So it's almost the first few percent of the age of the universe. So so I started with the nearby stars when I was small, and then now, you know, I had the opportunity to see this data coming from galaxy 13 billion light years away.
So,
quite exciting.
So what was your family like? What did your parents think when you told them that you wanted to be an astronomer?
So both of my parents were elementary school teachers. So actually, it was interesting because when I attended this summer school, Vatican Summer School, I met a few other students whose parents were also elementary school teachers or some kind of teachers. So I think, you know, family, well, having parents who are teachers probably has something to do with motivating their kids for doing, you know, science or whatever, something creative.
That's great. Do you have other siblings, brothers and sisters? Are they scientists?
No, actually, my sister is just homemaker, and then my brother has been working for a big bank in Japan. So yeah, I guess in that sense,
he pays for the work you do. Right. So when you were at the university, you already knew then astronomy, or that was just one of the options? I assume you did a physics degree.
I did my degree in astrophysics, astronomy actually. So I was already as a high school student, I was set to do astronomy, but unfortunately in Japan there were only 3 universities which had astronomy departments. So I had to get into one of them, and all of them were very competitive, but luckily I was able to get into one of them. So that's why I was able to do astronomy.
What made you be attracted to Hawaii to go for doctoral work?
So that was the time when the Mauna Kea Observatory was one of the premier astronomical observatories in the world. So now there's a big observatory in Chile, but the Mauna Kea was just becoming very famous, and also the Japanese astronomical community was planning to build a large telescope, which is now known as Subaru telescope. But so there was also that kind of special connection between Japan and University of Hawaii. So that's why I decided to go to Hawaii, and it was it was a very nice experience because these days astronomers observe remotely, so they hardly go to the summit of Mauna Kea. But back then, in order to observe, we had to go up to the summit of Mauna Kea, which is like 14,000 feet. So so I almost went up there once every few months, and just watching this night sky outside. That was a spectacular experience.
So when did you hear about the Vatican Summer School?
So I think, you know, the poster for the summer school was, I saw the poster on one of the bulletin boards at my institute, and that's how I got to know the Vatican Observatory Summer School. So I just applied. So it was just a poster put on a bulletin board at our institute.
What was the topic of that school?
So just mentioned, John Stockey was one of the instructors. So he was more like not quite cosmology, but extragalactic astronomer. So he talked about galaxies from. But of course, back then, the most distant galaxies we knew were much closer. So now we regard them as fairly moderate redshift galaxies, but they were sort of known as distant galaxies back then. So we studied those. He taught us about those distant galaxies, and then the second instructor was Bob Garrison, who was I think supervisor of Chris Corbally at University of Toronto. So
right.
Bob was expert of stellar spectroscopy. So that's what he taught us, stellar spectroscopy, although data back then was based on photographic plates. So we were just given the photographs of a bunch of photographic plates showing stellar spectra, and we were asked to classify those spectra visually. So those are the things we learned. So now I think about it, it's 34 years ago. So things were much different back then.
Right. What was it like? Had you ever been to Europe before when you stepped off the plane in Rome?
No, actually, that was the first time I visited. I had a chance to visit Europe. So in that sense, that whole experience during the summer school made a very strong impression on me. And as part of the summer school, one really nice thing about the summer school was that there were weekend excursions. So we were able to visit places like Rome, Florence, Pompeii. So the whole experience was really great, and I really appreciate Vatican Observatory giving me such a great experience, and that's part of the motivation why I want to give back something by serving, helping the summer school next year.
Well, you'd mentioned that Fernando was a classmate of yours. I imagine you must have made great friendships that have endured over the years.
Yes. So right after the summer school, many of us were in close contact, just sending emails and sending birthday cards and stuff like that. And over the years, we started to drift away. But actually, my first postdoc position was at Max-Planck-Institute in Munich, and Fernando was also at ESO, which was next door. So that was year from 95 to 98. So we were able to reconnect back then. And then after that, we also ran into each other from time to time. But I have to admit that I wasn't in contact with him as much as I wanted to. But yeah, that things happen. So.
Did your connection to the school have anything at all to do with eventually coming to the University of Arizona?
There's no direct connection between the summer school and me coming to University of Arizona, but yeah, but I knew that the Vatican Observatory was
located there, yeah.
Part of Steward, and I knew that Father George Coyne and Chris Corbally were here. So when I decided to come to Arizona, I was looking forward to see them again.
And of course, they knew who you were.
Yes,
obviously was a plus. All right, so you did your degree in Hawaii, then you went to Max Planck. Where else did you go before you wound up at Arizona?
Yes, so after Max Planck, I went to, well, actually at Max Planck, I was able to work with Professor Reinhard Genzel, who received Nobel Prize a few years ago. So the experience there was also very exciting. And then after that, I moved to California Institute of Technology, Caltech in Pasadena. So that's where I spent a few years. And Caltech and University of Arizona were the two places where infrared astronomy was started in the early days. So I first went to Caltech, worked in the infrared group there. The most famous professor there was Professor Gary Neugebauer. And so I worked with Gary for a few years. And then I moved to Arizona, which was another starting place for infrared astronomy. And the most prominent, the person who started infrared business here was Professor Frank Lowe. So Gary Neugebauer at Caltech and Frank Lowe at University of Arizona were sort of thought as two great founding fathers of infrared astronomy. So I was able to work with both of them, which was a great privilege. And actually, after I moved to Arizona, Tucson in 2001, after a few years, Gary retired and moved from Pasadena to Tucson. There was a retirement community here called, I think, Academy Village or something. So he moved. So he moved there, and so the Gary and Frank decided to have a weekly lunch. So I was also allowed to join them for lunch once every week. So it was really a great experience to listen to them talking about infrared astronomy in the old days. And that one spectacular. Yes, and one curious thing is that infrared astronomers, they don't consider themselves as infrared astronomers. They consider themselves as physicists, because first generation of infrared astronomers were actually physicists who started to do astronomy, and to their taste, astronomers are not rigorous enough. So just the astronomers tend to speculate all sorts of things because the data is poor. So when they say somebody is stupid or not good, they would say, you're an astronomer. So so astronomer for them was a derogatory word, but that was a very interesting story.
No, that's funny. So tell me how you got the idea to propose a program for the 2025 summer school.
Yeah, so actually, after one faculty meeting, I ran into Father Chris Corbally, and Chris told me that they were looking for a topic for summer school next year. So it just immediately occurred to me that the JWST is the most exciting thing that happened in astronomy recently. And the next year, although it's been already making great discoveries, it'll be the next summer will be 3 years after JWST started science operations. And so I thought that was a sort of good time to review the first series of great discoveries made by JWST. First 3 years. Usually when a new mission starts, the first few years is probably the most exciting period. So I thought the summer school VOSS 2025 was going to happen at the right time. So yes, so that's when I just casually suggested to Chris, probably JWST oriented topic would be a very suitable thing for the summer school topic. And then actually, when I proposed, I actually didn't necessarily said that I would do it. I just suggested that JWST would be a good topic to have. And then I guess either you or Chris told me that, well, probably you should think about writing a proposal. So that's when
Right.
I
Because you know what the summer schools are about. So you put together a team of people. It's not just you teaching the school, it's a great team. How did you find these people? And tell us who they are.
Yes, so there are two VOS alumni. Besides me, so the first one is Roberto Maiolino, who attended VOSS 2023. He's a professor at Cambridge University in UK right now. And actually, Roberto and I got to know each other when we were postdocs at Max-Planck-Institute, which I just mentioned.
Right. So you say he attended in 1993. You said 2023, which I don't think.
Sorry,
he would be a
1993.
professor.
Sorry,
Yes,
yeah.
right.
He attended.
That was my first summer school, so I remember him.
Yeah, so he attended summer school 1993. And then, but initially I didn't know that he was a VOS alumnus. So we got to know, we became very close friends at the Max Planck days, during the Max Planck days. And then at some point we started to talk, well, we found out that both of us attended Vatican Observatory Summer School, although in different years. Then so that was Max Planck, and then I went to Caltech, and then I moved to here. And Almudena Alonso Herrera, she also attended summer school, Vatican Summer School in 1993, same year as Roberto. And when I moved here, Almudena was actually my office mate. And again, I got to know her without knowing that she was a VOSS alumnus, but then again, at some point, we realized that we attended summer school in different years. So three of us, actually, Roberto Maiolino, Almudena Alonso Herrera, all of us have been working in infrared astronomy, and just it happens that our career paths cross each other. So that was a very interesting coincidence, but that's how the core of this summer school faculty formed. And then we also realized that three of us are all extragalactic astronomers. So we thought that JWST is doing so many exciting things, for example, with exoplanets or galactic star-forming regions, which are not our expertise. So then I contacted a few people through my personal contacts. So that Tom Green at NASA Ames, who's going to lead the discussion, the lectures for exoplanets. And there's another Maria. Sorry, I forgot. I don't know how to pronounce her last name probably. But
right. The long Russian name, I think.
Yeah, so she's Russian, Dutch nationality, but Maria will talk about galactic star-forming regions, astrochemistry, and things like that. So this group of five.
I had the chance to hear Tom Green, who gave a wonderful paper at the IAU last week in Cape Town. So I'm sure he's going to be a fabulous instructor. He gave a wonderful talk.
Yes.
And the topic, of course, that he's talking about are planets, which is the stuff I love. So
yes.
I'm very much looking forward to that.
And just to mention, I also have a special connection to Tom. So Tom was the staff member of IRTF at Mauna Kea when I was a graduate student. So that was, again, many, many years ago. We got to know each other. And then so the astronomical community is small enough that, you got to
everybody knows everybody else.
Yes.
Yep. So if you could put in a few words what it is that you hope the students who come to the school will get out of being there. Just sort of wax poetic for a moment. and try to describe what you think the school will do for these students, what you hope it will do for them.
So our goal is to give a broad and extensive view of the whole universe, from nearby exoplanets to the most distant galaxies, through the eye of JWST. So JWST has been making discoveries which are rewriting the a lot of things that were described in the textbooks. So already a lot of things become obsolete very quickly became obsolete very quickly once JWST became available. So we just wanted to give students the latest, most exciting discoveries made by JWST, and also we want them to appreciate the whole the universe as a whole, not as parts. So of course, we are working scientists, so we work with equations and computer codes and stuff, but we just want the students to appreciate the beauty and wonder of the whole universe as it is, just by looking at spectacular images produced by JWST. So that's sort of our goal. So it's not, you could probably sense this from the way we set up the curriculum. It's not focused on a narrow specialized field. Our goal is to provide the broader view of the whole universe. So that's what we hope to achieve.
Right. But of course, you're also giving them some very practical lessons on how to access the data and how to interpret the data, so that nowadays all these data are available online, but you have to know where to find them and what to do with them.
Yes, so that's our second main goal, which is, even if students go back to their home countries, home institutions, we want them to be able to keep going with their research projects. So our second goal is to provide enough information, skills for them to keep analyzing JWST data on their own. And this day of internet, it's much easier, and you can essentially download JWST data from anywhere. Actually,
as you know, a large number of our students, a majority of our students, come from the developing world. But this means that they can do this from Uruguay or from Eastern Europe or from India.
And they need to know what website to look at, what programs to download, and how to use them. So we plan to give them basic skills for doing all those things, and that's our second goal.
Right. Now, there are many summer schools out there. Some of them a week long, some of them a little bit longer. What is it in your mind that makes the Vatican Observatory Summer School different from those other schools? What is the one thing you think sets it apart?
So I think it's, I think the way I see it is that just for a period of almost a month, you're in this small community, isolated from the outside world, and you in a good sense, so that you can focus on astronomy for this fairly long period of time. And I think that's what I personally appreciate it, and that's what I want our students to experience, which is just this 1 month with colleagues from around the world. You just focus on something you're really interested in, you really care about, and that's a very special experience.
Yeah. And then, of course, as you say, you also get to go to Florence, and you also get to see all the sites around Rome, and you're with these students from around the world. and you discover, frankly, how much we all have in common because we all live under the same sky.
Yes, and also, you know, for example, I came, well, when I attended the summer school, I came from University of Hawaii, which was fairly advanced institute in astronomy, but there are students from, for example, Africa, some South American countries where students were really trying hard to keep up. And that made me realize how privileged I was to be able to work at a world-class research institute. So it gave even stronger motivation for me to keep going. So and also another thing is that you make lifelong friends, and this, for example, even though the years are different, Roberto Almudena and I have been in close contact for many years, and so there's a special bonds you form with fellow VOS colleagues. So that's another special thing VOSs really provide. And
there's one other thing. Oh, go ahead. Go ahead.
Well, and then one really spectacular experience was also, I wrote in my introduction that Fernando and I and a bunch of others, all our classmates, were invited to have a private audience with the Pope John Paul II back then. So we were able to go there, shook hands with Pope one by one, and that was a really spectacular experience. And we were able to see the inside of the residence, and that's another special experience.
There's one other very practical difference between this school and most of the other schools, which I have to mention at this point. It's free. We don't charge the students. Yes. And we even will supply whatever assistance they need to get there. We hope that if they come from a developed country, if they're fairly well off, that they can pay their airfare, at least part of it. But we'll supply the rest. No one is ever turned away because they can't afford the airplane ticket. There was, a time years ago when George heard from a student from Central Asia who was able to raise $50 for his airplane ticket. And George said, that's fine, we'll pay the rest of it. Because, $50 is a month's salary in his country. That's only possible, let me mention to the rest of the people listening here, because of the donations from Vatican Observatory Foundation donors. Anybody here who's interested in helping out for the next school, or if you know people who are interested, this is a phenomenal program. And whatever money you send to the foundation specifying the summer school is used only for the summer school and the summer schools. So I just have to remind you, this is one of those reasons that we're in the business, is to try to get the support for great schools like this. I have to ask one final question before we let you go, and you're getting close to the end. One of the people in the chat asked this, and it was one thing I was going to bring up. As soon as the original images of the distant galaxies from the Webb came out, there was a lot of press speculation that the galaxies are bigger than they expected. Or no, they're brighter than they expected. There was a lot of discussion about the nature of the galaxies, the early galaxies seen. And even people saying, aha, you see, the Big Bang was all wrong. Can you clear up some of that confusion? What is the exciting thing you're seeing, and what does it mean for our ideas of the Big Bang?
Yes, so it's true that the most is for this particular galaxy, the most distant galaxy our team discovered, it was just too bright. For example, when we first saw the images of this galaxy, we thought, there's no way that this could be at such a high redshift, such a large distance, because it's just too bright. But then we took spectrum, and we were pleasantly surprised that it's really far away. So it's true that this is a big puzzle right now in that such an early phase of the universe. How could such a bright galaxy exist? And when we say bright, typically that means that the galaxy is massive. And in order to form, so the current theory is that in this theory of structure formation universe, first small objects will be formed, and then they will merge with each other and produce larger and larger objects. So in order to produce massive large galaxy, it takes some time. And this galaxy was discovered only after 300 million years after the Big Bang. So it's just, there's not, well, it's not impossible, but it's difficult to produce such a massive bright galaxy in such a short period of time. So that's true. So that's one mystery. But at the same time, going from light to mass is not straightforward. So we know that it's bright, but is it really massive? There's a we can't really measure the mass directly. So we have to make some modeling there, and that there are some uncertainties. So that we don't, and also there are other scenarios where, for example, the galaxy is bright, but it's probably just going through very short period of star formation bursting period. So the light amount of light we are seeing may not be reflecting that the mass of the underlying galaxy. It's just some burst of star formation happening. So that's another way to get out of this large mass. Another thing is that so in the early days, the first few discoveries, there were some papers written about some massive galaxies exist at high redshift, which would violate the lambda-CDM cosmology. But it turns out later that many of these galaxies have black holes in them called AGN. So the AGN can emit a lot of light that would make the galaxy bright. So in those cases, the mass was clearly overestimated. So that it's clear that we are seeing an overabundance of bright galaxies in the distant universe, but whether or not they're really massive and whether or not they would really invalidate lambda cosmology, lambda CDM cosmology, that's still a question. And many of us do not believe that this will invalidate the cosmology theory we have right now.
Thanks so much for clearing that up. And I guess the answer really is stay tuned. There's yet another year of JWST results before we have the summer school. Thank you again so much for being part of this. And thanks to everybody on. This has been a really good turnout. Delighted to have you all. And we'll see you next full moon, all of you. Take care, everybody.